Next, we're going to move to Jenna Rodriguez.
Thanks, Erin. Hi, everyone. I'll spend about a minute talking about my story, and then I'll share what I do at Ceres Imaging, just so you have a little bit about my background and how I found myself in the private sector. So I studied remote sensing in hydrology at the University of California, Davis, specifically in the Center for Spatial Technology and Remote Sensing Lab under Susan Houston. And since the beginning, I always really just had a passion for working in between research and application in agriculture. So throughout my doctoral research, I was using remote sensing and finding new ways to use it practically in a way that made sense to farmers. Specifically, I focused on using remote sensing to help farmers manage their crops after earthquake-driven hydrologic events, because you can have all sorts of crazy things happen with groundwater and surface water and those sorts of things that can really disrupt your harvest or your growing season. So it was really fun to help growers see how they could use a really technical tool, being remote sensing, in a very easy and simple way. So for any students on this webinar right now, or on in this conference, I spent a lot of time, not a lot of time, but I really struggled to find myself, I suppose, in where my fit was. So I spent some time as a GIS analyst at Gallo Winery, and I dabbled around in teaching at Modesto Junior College and University of Pacific, teaching GIS remote sensing. And then found myself at Ceres Imaging in 2015, which I'll just asterisk while I was starting a young family. So it's definitely doable to juggle finishing your PhD, finding yourself professionally, and joining a fast-paced startup. It's definitely doable with the right network. So I came onto Ceres in 2015 at about 15 people. And what we do at Ceres Imaging is take aerial spectral imagery and do that same thing, help farmers understand that technology and use it in a practical way. So I'll share my screen to give you an example of what we do. Let's see, share screen. So this is an example of data that you can use from Ceres Imaging as a grower. And what was really cool about what we were doing was the Normalized Difference Vegetation Index, NDVI, has been the tried and true, most robustly used vegetation index in literature. But it was really, there was a little bit of NDVI fatigue with farmers. And there was a lot of growers just saying yeah, I've used this, but honestly, I didn't really understand what the colors meant, or when it showed me a problem, I already knew that problem was happening on the ground. So what we were doing in collaboration with the University of California to validate our transpiration models and chlorophyll models was to provide something that was a little bit more specific to a farmer. So with NDVI, you see a problem and you don't really know, is this due to my irrigation issue, or is this due to my fertility program? Do I go talk to my irrigation water management team, or do I go talk to my PCA or the people managing my fertilizer and soil amendments? Also, when you found a problem based on NDVI alone, you were a little bit behind the 8 ball in solving that problem. So like a farmer said, when I already knew about it on the ground, when you're trying to solve a problem that's been occurring consistently through the season and you're seeing it in the biomass, you've already incurred a yield hit, right? And so with the cooperative extension, we created water stress models and chlorophyll models to help be more proactive. So using really high resolution sensitive thermal imaging, we were able to see very tiny changes when the stomata are opening and closing to look at that temperature gradient between the canopy and the air. So as soon as a line is clogged up, or as soon as there's a leak happening, you can see that through the imagery. So what's really amazing is the farmer can go out and fix that problem before you ever see it show up in NDVI, which is the goal, and getting that return and preventing any sort of yield problems. So that's what's been really exciting. However, when farmers mention, we see all these colors, but I don't really know what it means. we really have been working hard on our mobile app and our web app to turn that imagery around within 24 to 48 hours very quickly, because things happens fast in agriculture, with pins and notes, so like comments and flags, where the farmer, as soon as they get that imagery within 24 to 48 hours, there's a pin flagging that red area that you see, that red corner in the water stress, saying possible pressure loss on this irrigation set, or these two irrigation sets look like that there's a pressure loss occurring. Go check it out. So helping the farmer understand what layer to use and what could potentially be happening. And then with that pin, they can geo-reference out to go solve that problem. So really helping to quickly build up that imagery literacy at scale, which has been really exciting and really difficult to do with remote sensing. And so that's kind of where I found my spot in working with growers across all different crop types in Australia, United States, and Canada, to help use remote sensing in a practical way.
Fantastic. Thank you, Jenna.